Hello grade 8s, this is Mr. Miller and welcome to lesson 8.3 on exploring integer division. So first off, it says, what division statement does each of the following diagrams represent? And so when we're talking about a division statement, here's what we mean. We're talking about the dividend divided by the divisor equal to the quotient. Now I've color-coded these and you'll see how this works out as we do our examples, so pay attention to the colors. Now, the other thing to keep in mind is that either the divisor is the number of groups that you're dividing up the chips into, and the quotient is the size of each group, or the other possibility is the divisor is the size of each group, and the quotient is the number of groups. So the division can be done in two ways. Either you're dividing into a certain number of groups, or you're dividing into groups of a certain size. So when you look at the first one here, part A, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We've got 12 negative chips. And you can see they're being divided into two equal groups of size -6 each. So there are two ways that we could write this division statement. The first way is with the divisor, that's this part here in red, which is the number of groups. So if we're taking our -12 chips, which is the dividend, we're dividing into two groups, so one group here and one group here. Then the quotient, which is the answer to the division question, is the size of each group, and that's -6. Or the other way that you can interpret this, in part B, the divisor is the size of each group. So here we're starting with the same dividend, but now we're saying we're taking our -12 chips, and if we're dividing into groups of size -6, then we get two groups. And so the quotient is the number of groups this time. So hopefully you understood that. Try to do the same thing with part B. So first off, you can start with your 14 positive chips, which is the dividend, and divide it into 7 groups, and the size of each group is 2. Or you can divide it into 2 groups of size 2, and the answer is the number of groups, which is 7. The next one, part C, we've got -5, which we're only dividing into one group, size -5. So dividing by one group, you get a group of size -5. Or you can say, take your -5, which is your dividend, it's the number of chips that you're starting with, and divide it into groups of size -5. How many groups could we get? Just one. Now the last one here is kind of interesting because it doesn't matter whether you make the divisor the number of groups, 3, or the size of each group, 3, because they're both the same. So that's sort of a special case scenario that in this case it's exactly the same. So there is only one division statement that this diagram can represent. So now at this point you might be thinking about what are the rules for division. Here's a summary of the division rules. So first you'll notice that a positive divided by a positive has been modeled as being a positive. So we can see that one here. We also saw that if you're doing a negative divided by a negative, you get a positive. So here's a negative divided by a negative, and the answer is a positive. And if you do a negative divided by a positive, So negative divided by a positive, we got a negative answer. There's one that's missing here. And that's trying to do a positive divided by a negative. So you notice there are no examples of that here. The reason is that a positive divided by a negative is actually a negative, but it can't be modeled with this integer, with these integer chips. And that's because of the fact that the number of groups would have to be negative. And that is impossible. You can't have a negative number of groups. You might be thinking, well, how can we get around that then? How can we do something like, 9 divided by -3? And, well, you can think about this as being the opposite of -9 divided by -3. And we can do that one, right? -9 divided by -3 is 3, and the negative sign would just be left out in front. So, anyways, that was just sort of an extra example in there to show how you could work out that when you do a positive divided by a negative, you get a negative. The next question is asking, what color of integer chips would you use to model each division statement? Well, in each case, the dividend is the number of chips that we're starting with, and that really determines its color. So I know this is black and white here, but if we want to represent negative, we can either draw little circles with negatives inside, or we can draw circles that are blue. And in the textbook, you'll notice that the circles that are blue are negative integer chips. The circles that are red are positive integer chips. And again, the color of integer chips is determined by what is your dividend, the number that you are dividing up. So since this is negative here, we need to use the blue chips. Next thing, we got a few more questions. First of all, it asks, in Winnipeg, the temperature at 10 p.m. was -16 degrees Celsius, and at 1 a.m. the temperature was -25 degrees Celsius. We want to first of all determine how many degrees did the temperature drop. And so I've added a little hint in here that the temperature change is equal to the final temperature minus the initial temperature. So if you take the final temperature of -25 degrees Celsius and you subtract the initial temperature of -16 degrees Celsius, then you'll find that difference is more easily found if you add the opposite. So -25 adding +16 will give you -9 degrees Celsius. So now we'd like to know how many degrees per hour did the temperature drop. And so in order to do that, we take the -9 degrees Celsius and we divide it by 3. Going from 10 p.m. to 1 a.m. is a 3-hour period of time. And so that's -3 degrees Celsius per hour. By the way, I never really mentioned why it's a negative here. So the fact that it's a negative is just corresponding to the fact that it's temperature drop. So now on to number 4. It says, how do you show 0 using integer chips? Well, that's with a positive and a negative chip. That's a 0 pair. Now it's asking, how could you show 0 divided by 2 using integer chips? So 0 can be shown in many ways, but for instance, if we have 2 pairs of zeros, 2 pairs of 0 pairs, then what we can do with that is we can split it up into 2 groups. So dividing by 2, that's the number of groups. So this is showing 0 divided by 2 is equal to 0 because you're starting with 0, you're dividing it into 2 groups, and the size of each group is a plus and a minus. That's 0. So again, this is the number of groups, and this is the size of each group. Hope that was all clear. I know this can be a little bit tricky with integers, and if you have any questions, please don't hesitate to ask me. Thanks for watching this video, and have a great day.